Thank you. Let me share my screen. All right. So today I'm going to show you one idea what could be done with AI. I think we will all agree that everyone wants to use AI these days, but it's a bit challenging to decide where to use it, how to leverage AI nowadays, how to turn hype into actually something valuable. And it turns out when you speak to developers around the world, they are all pressed to implement something AI. So I hope that this evening, not only I will show you one use case of GenAI usage, I hope I will also spark some ideation among you, and maybe you can also get back to us on the Discord later on to tell us what could be ideas for future demos. What you can see on my screen is Node.js application running. Now, this was started as a small demo project, but over time, I think it will grow up to be really, really a comprehensive demo. And this is something we showcase on our previous session, I think. This intelligent help desk is something I'm going to demonstrate this evening. And this is shape of the things to come. So just to sparkle your imagination about things coming to RavenDB. So this evening demo will be help desk, but with some AI sparked on it. So in help desk is a domain that more or less we all know. It doesn't have to be help desk. Any place where there's a lots of tickets, there's always a challenge. So probably you have been using over the course of your career something with tickets or something with issues like either U-Track. This is, for example, something that we at RavenDB are using, or you been using Trello with the cards, and over time, it's always the same problem. You're overwhelmed with cards. It's hard to find your way, and we are all spending lots of time trying to do some kind of triage to see, okay, it's Monday morning, what I should be working on, or what's most urgent. This is real life problem. This is real energy drainer, at least for me. So what I have here is RavenDB running our standard sample data set, Northwind. I don't know if you're aware of it, but Northwind is a database of a fictional company doing food trading. And we decided to expand this example a bit. So we decided to introduce a help desk ticketing system integrated with this. Whole idea is this company is doing food sales. There are customers, companies trading with us, and we want to support them by offering them ability to create tickets, and we will react to these tickets. How did we model it? Well, we have here collection of help desk tickets. And each one of these tickets is looking like this. So there's some title. There's the name of the customer, creation date and updated date, connection to the order, because in most of the cases, our customers are having inquiries or complaints or interest over specific order. And what you can see here is the conversation history. Now, this can be emailing back and forth, or this could be portal where they can log in and place their complaints or remark. It doesn't matter. Format is simple. You can have here sender name, because when you're doing business with companies, it's usually multiple people you talk to. The most important thing is this, content. And you can see already what shape this is taking. So Sarah Johnson is complaining that she placed an order 5 days ago and stating the ID of the order, and it still hadn't arrived. And this is Mike Thompson from our company. apologizing for the delayed order, and he is promising that he will take a look immediately. And this is response from Sarah. And of course, there could be multiple people on both sides. And you saw how long it took me to overview this single ticket. And you can understand that if we are having support around the clock, multiple people from our company will switch. And they will need to be able to comprehend this rather quickly. Or imagine receiving a phone call. So Sarah Johnson is now calling to see what's going on with the order. In ideal case, our support staff will be able to go to some kind of portal, open this ticket, and quickly comprehend what is going on. So how to improve this ticketing system, how to introduce more helpful information. And overall, for example, when our salespeople sit down to inspect tickets, what would be the fastest way for them to determine what tickets or what cases to handle? So our tickets could be expanded with some additional information. So for example, this would be one possible extension. This is summary of this support ticket based on all these conversations. Imagine you reading all these emails going back and forth and then summarizing. Customer Sarah Johnson is frustrated about the delay in the delivery of her order, which has not arrived 5 days after placement. And you can see it's also description here. Why is she frustrated so much? Because delay in this delivery is impacting her special event. So she orders some food for a special company event, and you can see delivery is late. She's upset. This is valuable summary. So you see right away the value of this summary, because I don't have to go and read all these emails. And in this case, I have 3 emails, but imagine having 7, 8, or even more emails. This is first valuable piece of information we could enrich our tickets with. Here is priority, and it's obvious why priority is high, because this customer is very frustrated. She was counting on us. In this case, this specific ticket does not need any salespeople. Sale has already been closed. We are in the support phase. And we can also tag this specific order or specific ticket with some tags. So in this case, we have tag for delivery, because this is what we are solving at the moment. But we also have a tag of refund, because this is possible case where customer will ask for refund. She's dissatisfied, obviously. And it's great to have helpful information like this, but the question is, who will generate these? Well, we're living in the age of the AI for past 2 years or 6 months, depending on what you're counting. Do you look only at vibe coding or GPT era? And we can offload these tasks like these to AI. And in fact, this is perfect example of the type of helpful actions that we can leverage AI for. What most people are not aware is that AI is not something that can completely replace humans at this point in time. So AI, no matter what you use, it still needs human oversight. It needs human governance. So it cannot replace us, but it can act as, let's say, some kind of junior assistant to us. So in this case, we are looking at a rather elementary summary. This could be done maybe by a high school student, and trying to extract or categorize priority based on the tone of this conversation. Also, maybe high school student can also determine if this is where sales is needed. And you can see these are not too critical tasks in the sense that this is not related to possible violations of any kind of regulations or codes in this industry, but this is helpful way to lower amount of the work that our sales and support people need to do. So how to use now expanded support tickets like these? Well, if you look at my application, if I type in something like refund, I would like to see all the tickets where possible refund is being discussed. You can see various tickets here. What is great is without need for me to go into the ticket itself and read conversation, or here, multiple emails, I have AI generated summary, which is coming precisely from this field, which is giving me easy overview, summarization, summary of the whole conversation going on the ticket. So I have clear overview. I may be on the call. I can read these couple of sentences and figure out what is going on. That's the first thing. The second thing is priority. So I can filter by priority. And again, this priority was determined by AI. It's coming from this property. So, of course, triage has already been done by AI. Now, if I have short period of time, I'm able to find most urgent ones to work on them. She's frustrated. It's going on. Let me handle it as soon as I can. So I can see frustration. I can see it's in progress, and I can see it's high priority. And of course, a refund is being matched, and I'm getting back this specific ticket. Or let me see who is dissatisfied. So I'm having this one. Dairy products are found, cream cheese containers were leaking. So what you can see here is this text here, this summary is giving impression of someone who is dissatisfied with our service, overall service. Containers were leaking. And pay attention to the fact that the word dissatisfied is not appearing anywhere in this summary. So I also have semantical matching. And I will show in a moment how all of this is composed together, but you can already see the value of this implementation of Intelligent Support Desk. Or dissatisfied, here you can see word frustrated. So again, I'm searching for customers who are dissatisfied, and I'm giving someone with a leaking container, and this customer requested a replacement or a refund, so possible dissatisfaction, depending on the way we will handle this. And we can see here one more, Sarah Johnson. And this is precisely this sample ticket I was showcasing. And I also pay attention that AI correctly assigned priorities. So if I need to work on one of these two orders, this one would be a proper choice. Because here we are speaking about someone who planned complete event with the food, and now the food is missing. I think you will agree this is slightly more urgent and important than this non-urgent replacement or refund we will execute. And of course, besides this, you remember I also expanded with need sales Boolean flag. So if I go into, let's say, inquiry, this is this would be something that salespeople would be interested in. Prospects who are interested in things, and our salespeople should handle it. You can see here, these yellow boxes are being rendered based on need sales true value. So I have a button here where I can click and filter out. So imagine me being a salesperson. You can see how a short amount of time it took me and how easy it was to filter out all inquiries where sales people are needed. And again, you can see here inquiry in the title of this ticket. It's clear why this one was selected. But if you read the title of this one, so it's a contract negotiation, and this person is reaching out to establish monthly catering contract for the office. She's requesting someone from the team to contact her regarding this potential agreement. This is perfect example of sales related task. And you can also see that in both of these cases, priority of the ticket was determined as medium. So we are speaking here about additional functionality on top of what we already had. We had a support desk with ability to create tickets, with ability to store complete history of the communication. But what now we have automatic summarization. So I don't have to go into ticket itself to see what's the content. I have automatic qualification if this is something for me as a salesperson. And we also have prioritization. Again, if I'm looking for people who were overcharged, I can quickly filter it out. You saw how fast it is. And of course, as what is also important, as amount of tickets grow over time, this will remain fast because Raven is executing all of these queries over pre-computed indexes. So that's a guarantee that queries will be filtering queries like these. This one will be fast despite a growth in number of tickets over time. And you can see how quickly I can search for now. I will over the years of working with this support desk, I will figure out what are the most common topics that customers or prospects need care over. So the key here is I'm using already existing domain, which is support desk, and I introduce AI-powered power features, which will speed up the things. So in this case, AI is not replacing me, and AI cannot replace my work. And we also see some, I wouldn't say catastrophes, but negative cases of companies trying to replace support, for example, with AI. That's not what's happening here. What happens here is set of features which will make me more productive, more efficient. That's the whole idea. I will still do my work, but you could say I have some kind of junior assistant which will make me more productive. So how was all of this implemented behind the scene? So first thing, we have these tickets. And if you look at this ticket I was showcasing here, this is the baseline version of the ticket, and this is expanded one. You can see expanded one here. These fields were generated by the use of AI. So first, how to enrich our tickets with AI-generated content. This is precisely the name of the feature, GenAI, generated AI content. RavenDB in version 7.1 is capable of talking directly to external large language models. And this is ETL on steroids. If you ever use RavenDB, you're familiar with all the ETLs that RavenDB is supporting. Look at all the integrations that RavenDB can perform towards external systems. But GenAI is one step beyond that. Because not only that RavenDB will extract data from your collections and your documents and will push them to LLM, it will also be capable of receiving response back from LLM and storing it inside of your documents according to your instructions. You will see in a moment how low amount of code is needed, and RavenDB will, once you set it up, will handle all of this automatically. So first thing you need to do, you need to establish connection string towards external LLM. Here it is. What you can see here, I'm using OpenAI, I'm using GPT-4o Mini, which will generate content like this one. The great news is you have option to connect to any kind of external systems. You can see Azure OpenAI, Google AI, OpenAI Mistral, or, and this could be especially interesting to you if you want to keep your data from exiting your ecosystem, your organization. You can use Ollama local installation. You can install LLM locally inside of Ollama and establish conversation between RavenDB and model running inside of Ollama. I think this will be interesting thing in years to come. But for this evening demo, this is what I'm using. OpenAI GPT-4o Mini. Of course, you can use a number of the models available at OpenAI. So you set this one once, that's it. And if you noticed in the studio in version 7.1, we have AI Hub and AI tasks. So here is the task which is generating these summaries and other information for each one of my tickets. As you can see here, set of the steps that will happen over time, and you have a wizard, so you can go step by step. So in the first step, I will pick up connection string. So I'm saying, okay, this GenAI task will use OpenAI. What you can see here is the default value of max concurrency. And you will also notice that we introduce lots of preset parameters. In this case, this is something that you may or may not want to tweak manually, but we are leaving you with the default value. So in this case, I'm using 4 concurrent requests going to OpenAI. Now, I'm approaching definition of the GenAI conversation between RavenDB and OpenAI, and I need to define a couple of things. First one is so-called context. So I'm going, as you will see in a moment in the next step, I will define a prompt. Absolutely similar to what you would do manually with, for example, ChatGPT or COD AI, writing a prompt instructing LLM what to do. Context is a set of data that our prompt will operate over. So if you look at this original ticket of mine, let's say I would like to generate summary on my ticket. I want to instruct OpenAI what to use to generate this summary. data that will be used to execute my prompt is called context. So what you can see I'm doing here, first, I'm determining which collection will be processed. In my case, this is collection help desk tickets. And this means that this GenAI ongoing task will take one by one tickets as they are created, as they are modified and saved. Every time ticket is either created or modified, GenAI task will be triggered for it. And this is what will be executed. So look what I'm doing here. I'm taking conversation history. Here it is. And you can already see for the task of computing or coming up with the summary, timestamp is not something that I need, or message type text. I will not need to use all of this information. Of course, I could send this array, this collection of communications as it is, but no need to do it. So what I will do here, I will pick up message.content and message sender name. So I'm pulling sender name and I'm pulling content from each one of these messages from conversation history. So these two will be picked up, these two will be picked up, and these two will be picked up. And this is my free choice. This is my, I can go back and edit this to add more information if needed, if I see that things are not good enough. But for now, let me go with these two. So the message content and the sender name. And I will loop over all these messages and push this object into the array. Here it is. So what will go as a context to LLM? I will send the title. Here it is. That will be the first thing. I will send the customer name. Here it is. And of course, this will be later on matched with the sender name of the message. And third thing, I will send message history that I populated by extracting content and the sender name. And you can think about it as someone human going into this JSON and cleaning things up, leaving only what is relevant for the summarization of this ticket.
Dayan, sorry to interrupt. There is a question on our chat. Could you go that?
Could you be so kind to read it to me?
Of course.
Because
Crispy is asking, is the upsample application available? Because he would really like to make a demo to Bootstrap. Yeah, I know already answered to that question. Yes, the application code is on my repo. I will send you a link in the chat. And also the second question is, are you connected to OpenAI using a free account, or does this type of integration require a paid license?
So the question is about the RavenDB license.
I'm not sure. Chris, could you clarify if you mean okay? Chris is taking voice, so let me invite him to the stage.
Hi, can you hear me okay?
Yep.
Yeah, so I was wondering, the license or the account that you're using to connect over to OpenAI, do you have to pay additional for that, or is this the demo that I can stand up on my own?
What I'm using at the moment is if you look at the connection string, I'm using OpenAI API key, which is connected to the pay account. I must admit I did not check free tier recently, but you will see that I'm not doing anything extraordinary. This is simple, uploading context, sending context and the prompt.
Yeah. I'm trying to figure out how much work it's going to be for me to stand up this demo myself.
Essentially, this is the only thing that is needed. So setting up connection string, and we can also expose the details of the task that I'm now explaining.
Thank you very much.
Sure. So this is something that, okay, you need to learn this syntax, but you can see this is pure JavaScript. The only thing that is specific to RavenDB here is this, AI.genContext. Everything else here is just JavaScript. So this is first thing you need. The second thing you need is a prompt. So here is the prompt. Same one you would hypothetically type into the ChatGPT. Given the help desk ticket details, title, sender, and message history, provide a brief summary approachable to anyone who wants to know what's the ticket about. And highlight customer needs. Let's call it summary. So what I just selected is precisely the prompt that will summarize a ticket like this one into something like this. And again, I think you will see once you start playing with this, you will see that the most amount of time you will spend is actually crafting high quality prompt that will give you results which are good enough. Also, you remember I was mentioning other fields like priority and need sales and tags. Here is the rest of my prompt. Measure the importance of this, you assign a priority. And here is, again, the biggest challenge is to treat LLM as a human being, to explain it in such a way. That's why I keep going back to the high school student. This would be the way you would explain to a high school student what is low, what is medium, and what is high priority. So this will be priority, assign tags to the issue. And what I'm stating here is the range of the tags. So things, again, are under control, and this is something that I can build into my source code. And finally, indicate if the conversation needs intervention from one of our sales. And here is criteria: large orders, continuous contracts, negotiations, pricing. All of them should be flagged as need sales equals true. And if not, still return back to me, but with value false. So you remember, I had the context, which is data that this prompt will operate on. So the context is first thing, the prompt is the second one. And there's just one more thing. Since now we have two computing systems communicating together, what I need is specification, or to be more technically precise, JSON schema of the response format I'm expecting back from LLM. You have two options. You can go and define schema like this. But since we are humans, here is the sample object, sample response object, RavenDB will deduct schema automatically from. So what you can see here, I'm stating that essentially the summary will be string. Priority will be string, tags will be array of strings, and need sales will be Boolean. All of that is extracted here, as you can see, with the types, type array for the tags, array of strings, and this is it. With this, RavenDB will be able to take every single ticket, extract the content by executing JavaScript you saw a moment ago, accompany that with the prompt and with the schema that it expects back from LLM. And LLM will receive our message or RavenDB request. It will process and it will respond back. Now, one final thing that is needed is to define how RavenDB will respond back to the response it receives from LLM. And I'm defining here JavaScript again. $output is the JSON that is being returned, and you saw the JSON schema, so JSON formatted according to schema that will be returned back from LLM. Now, what I can do with this JSON, well, anything I want, because I have JavaScript here and I have RavenDB engine. So I could, hypothetically, in different scenario, I could save JSON response as separate set of documents in separate collection. In this case, I'm deciding, or I decided in the beginning, that I want to enrich my documents. So you can see summary, priority, tags, and need sales, precisely fields that I said that I would like to introduce, being created by assigning result object .summary, .priority, .tags, and need sales. These are being guaranteed by the schema that we specified here. So we can count them. And what you just saw, this update script is the final thing that you need. So you need just 4 things: context, prompt, JSON schema, and JavaScript that will be triggered when LLM responds back. So now every time ticket is created or updated, GenAI task will be triggered. A request will be sent to LLM. LLM will take our context, supplied context, process the prompt, and return back response in the JSON schema format. RavenDB will trigger execution of the JavaScript, and it will enrich. In this case, it will enrich our support tickets. This is something that is non-trivial work. This is major speed up. I will benefit from this right away. And I'm returning back to my claim that you will probably spend most of the time on this crafting prompt. But you saw how small amount of the code I need is. All this communication back and forth, retries, even caching, which is also important detail, will be handled automatically by RavenDB once I set this up. So this is enrichment of the tickets. And here I have a code which is running my portal, but none of that is contained in the project. So complete communication between RavenDB and LLM is defined in these a couple of wizard screens. Now the second part is, you remember, I typed here overcharged and that was matched, but they go into, let's say, frustration. Frustration, you can see I typed in frustration. I got back someone who's frustrated, but let's say dissatisfied. I typed in the word dissatisfied and I'm getting back someone where it doesn't say I'm dissatisfied anywhere. Or you can see frustrated and you can see smelling, you have semantical matching. And this is the second part of this application. So for the second part of the application, for intelligent support desk, what I'm having is I'm leveraging vector search. Vector search, we mentioned it in previous sessions on Discord, is this semantical matching. With it, you almost have an impression that your application is able to understand you. So when I type refund, or if I type a problem, keyword problem, I will get everything that smells like a problem. This is the power of vector search. So whenever I type here, vector search will be performed. Here is the actual code that is executed. So this is amount of code you need to execute a vector search. So session is opened. I'm going to query help desk tickets, and I'm performing vector searching over summary, the same summary that was generated by GenAI. So I'm matching query text with vector search over summary, and this is threshold. So I'm having cutoff point, because similarity is not a binary concept. Similarity goes from, let's say, 0% to 100%. So in this case, with some empiric experimenting, we can see in this specific domain that 60% and over would be something that works for us. Again, minimum amount of code needed here to work with vector search. What is needed to get this working is, again, very brief effort on your side. If you look at this here, this is one more interaction with AI. Because it is one more interaction, I need one more connection string. So here is connection string, again to the OpenAI. What will be happening here is that we are going to use OpenAI text embedding model to generate embeddings. Embeddings essentially are nothing more than a very large array of floating numbers. And this very large array or collection of floating numbers will, by some magic of AI, encode semantical meaning of a phrase or piece of text. So once I define connection string, I just need one more task. Here it is. I want to generate embeddings for summaries so that I can perform vector search over it. And again, we try to encapsulate all the complexity of the AI so you don't have to learn too much to start using. And what you can see on your screen is even simpler than previous GenAI use case. So this is all you need. You need to define what connection string are you going to use, what collection will be processed. So again, I'm processing these tickets, and I'm defining here that I want to process summary, which is of plain text type. And this is it. I will not use quantization. I have default parameters for caching. You can see here, cache expiration is 90 days for embeddings for the summaries. And whenever I send a query, like this word problem, this will be sent to LLM to compute embeddings and stored for 14 days in RavenDB. But the best part about this is that we are using this characteristic for RavenDB, convention over configuration style. Everything is configurable, but we are also supplying you with a reasonable set of default. So what will happen now? Since this embeddings generation is processing summary field, and again, I'm speaking about this field, summary, the flow will be like this. So first, a ticket is created. This is first step. This is now triggering AI gen task, which will enrich tickets with summary and other fields. So when ticket is enriched with summary, it is saved again. And now this will trigger compute embeddings. Because we are monitoring, or RavenDB, we define this task that RavenDB is monitoring summary field of the help desk ticket. So GenAI will catch any ticket which is created or modified. It will send it to LLM to be processed. It will enrich ticket with computed summary and other fields. and the change in the summary field will trigger embeddings to be computed. And again, RavenDB will talk to OpenAI, compute embeddings, they will be returned, and they will be stored into this collection. This is artificial document that was created to save response from the text embedding model on the OpenAI side. And you can see here, this JSON document is carrying attachment, and this attachment contains actual embeddings stored here. And this is it. So the moment I'm typing here problem, I'm triggering this function which will be executed, which will take my query and use embeddings computed by this task for the summary to match my query with any of the summaries with similarity of 60% or higher. This query will return set of the matching tickets, which will be rendered on the screen. So essentially, you could say when you narrow down to the code that I had to write specifically for this AI-powered search, it is this. Before this, I would probably implement here full text search. Let's say that this was initial state of my help desk ticketing system. So here was, instead of vector search, it was full text search. I was searching over all these messages. If you look at the help desk, old style solution would be full text search over all of these. But you can already guess that this would not be too precise. Too accurate is a better word. So I set up GenAI for summarizing tickets. I set up computing embeddings. I need to define these two tasks just once, save it, and that is it. Things will be triggered and executed automatically. And now I can go and change original code that contained full text search into this vector search. So not only that in this case, I'm using GenAI to generate this summary, which is giving me a nice overview of the whole chain of back and forth communication. It's also qualifying priority and if any of the salespeople are needed. I'm also leveraging this GenAI generated summary to perform vector or semantical search against it. So again, not only that my employees or me specifically as a salesperson will benefit from this, we will be more productive. We will be able to understand things much better. If I go to summer vacation and my colleague replaces me, continuous communication with Sarah Johnson, my colleague will be able to maintain the same style of the communication because he's able to scan quickly what is going on here. Not only that, but I also have very good search now, which is intelligent, which is understanding semantics, which is able to understand where the problem is, even though you can see a rather neutrally written statement. But it's able to find meaning, understanding that this is high priority problem. This is someone, Sarah is counting on us. She's planning event with the food and food is not arriving. So I'll be able to spot on what is of high priority and handle it. And again, this is not replacing humans. This is almost like every single human having an assistant. An assistant will prepare, triage, pre-process things for us so that we can do our jobs better. Okay, Gratian, any questions? Because I think I wrapped it up.
Yeah, I think that there is no question yet because, as usually, I guess we're gonna get more questions on our Dev Talk channel. So, right, if you are already finished, yeah, thank you, Diane. It was a very amazing demo. It was super enjoyable. It carried a lot of value. So huge appreciation, not only from me, but also you can look at the chat. People are also appreciating your demo. So the people that are with us today, maybe let us know how did you enjoy the event, and as Diane stated, what do you think about the feature itself? You can drop your thoughts on the Dev Talk channel. If you are watching on YouTube, for example, you can join our Discord and chat with us down there. Let us know where you would use the GenAI feature and what use cases come to your mind. Yeah, and I think that's it. So have a great evening, everyone, and see you next time in another episode. Bye-bye.
Thank you for your time, and see you on one of the next events.
Yeah, bye.